Welcome back to the deep dive. So today involves, well, a pretty serious mental shift, I think.
Too big there.
We're looking at a script titled The Logic of Connection, which comes from this larger work, Dalla linea alla melodia.
From line to melody.
And I have to say, reading through this, I felt like I was, unlearning everything I thought I knew about how digital music gets made.
It's a dense text, isn't it?
Yeah.
It's technically about coding in pure data using the PDida library.
Right.
But really, it's a treatise on philosophy masked as a technical manual.
Mm.
It tackles the biggest misconception people have about computer-generated art.
Yeah, let's start there. Because usually when we talk about generative music or algorithmic art, the immediate assumption is
Randomness.
randomness. You picture a computer just rolling virtual dice.
Exactly. We think of chaos. We think of, stochastic processes, giving up control to the machine and just seeing what happens.
A sort of let's throw notes at the wall approach.
Yeah, pretty much.
But this source material opens with a concept that is the exact opposite of that. Absolute determinism.
Which is a heavy phrase.
It is. And to be honest, when I first read absolute determinism, my heart sank a little. It sounds
Robotic.
robotic, yeah. If every single sound is strictly determined by a rule, doesn't that just kill the vibe? Doesn't that mean we're just listening to a clockwork toy soldier marching in a circle?
And that is the paradox we're unpacking today. Because you're right, determinism should sound mechanical. It should sound predictable.
It should.
But the argument here is that if you design the logic of connection correctly, a strictly deterministic system doesn't sound robotic at all.
Yeah.
It sounds like an ecosystem.
So the claim is that you can have zero randomness
No dice rolling.
and still get something that feels organic and, alive.
Precisely. The text argues that the life in the music doesn't come from accidents. It comes from the complexity of the relationships between really simple parts.
Okay, well, let's test that theory.
Yeah.
Because the simple part they start with is, well, it's absurdly simple.
Mm.
The source calls it the linear DNA,
The counter.
the counter. We're talking about a string of numbers, 0 through 11.
0, 1, 2. All the way to 11. And then it just resets.
Okay, I want to pause on this because it just seems almost too basic,
It does.
to function as a score for a complex piece of music. If I sat down at a piano and just played the first 12 keys in order over and over again,
No one's going to be impressed.
no, nobody's going to call that a symphony. They'd call it a tuning exercise.
Let's call it boring.
Exactly. So how does counting to 11 become a complex polyphonic dialogue? I feel like we're missing a step here.
We aren't, actually. We just have to change how we view the data. You're thinking of those numbers 0 to 11 as a result. Like 0 is a C, 1 is a C sharp.
Sure, that's how MIDI works. Note 60 is middle C. It's a direct mapping.
Right. But in this system, the counter isn't the music. It's the DNA of the music.
Okay.
I mean, think about actual biological DNA. It's just 4 chemical bases, right? A, C, T, G. If you look at the raw code, it's just a boring string of letters.
Right. It doesn't look like a blue whale or a redwood tree.
Not at all.
Hmm.
The complexity isn't in the raw string. It's in how that string is interpreted.
I follow you.
So the source material explains that this simple linear ramp, this 0 to 11 count, is passed through a kind of lens, and that lens is the PDida library. The library takes that boring, predictable input and refracts it.
So the counter is just the fuel.
Mm,
The engine is where the interesting stuff is happening.
correct. And this is where we get into the module they focus on so heavily, the expression object.
The expression module. Okay, this is where I started to see the huge difference between this approach and, say, a standard digital audio workstation or a DAW.
How so?
Well, in a standard DAW like Ableton or Logic, you've got a grid. You have a track for pitch, and you have a timeline for rhythm. They're totally distinct.
Yeah, separate lanes.
I can write a melody, and then I can drag those notes around to change the rhythm. I can make them whole notes, 16th notes, whatever. The pitch doesn't care how long it lasts.
The parameters are independent. That's the standard paradigm of music production, for sure.
But the source text here talks about pitch duration interdependency, which sounds like, a lot of technical jargon.
It does.
But the implication is wild. It says, the melody is not placed on top of a rhythm.
The melody is the rhythm.
Exactly.
And this is the whole crux of the expr module. It's a logic gate. It takes that input number, say a 5, and it runs a calculation.
Okay.
That calculation outputs a pitch value, but simultaneously, part of that same equation outputs a value for the pulsa object.
The pulsa object being the pulse generator, the thing that makes the sound happen.
Right. So let's just conceptualize this for a second. Imagine the math dictates that higher numbers equal faster pulses.
Okay, so if the counter hits 10 or 11,
The pitch goes up, and the rhythm creates this little burst of speed.
and if the counter drops to 0 or 1?
The pitch drops, and the duration elongates. You get these long, drawn-out low notes.
So you can't just change the rhythm.
You can't.
The rhythm is baked into the note itself.
Exactly. And because it's all driven by a mathematical curve, maybe it's a sine function or polynomial inside that expr object, the acceleration and deceleration aren't, like, stepped. They're fluid.
Ah, that explains the organic growth the text mentions. It's not a metronome ticking away at 120 beats per minute. It's elastic.
It creates rubato. In classical music, rubato is when a performer speeds up or slows down for expressive effect.
Sure.
Here, the performer is the math. The density of the notes just breathes based on the pitch content.
Which is why it doesn't sound like a robot. A robot keeps perfect time. This system accelerates and decelerates like a person getting excited or, calming down.
But, and here is the kicker, it is entirely deterministic.
Right.
If you ran the code 1,000 times, it would accelerate and decelerate at the exact same moments every single time. It mimics the feel of human improvisation, but it follows the strict logic of code.
That is slightly unsettling, but also very, very cool. However, I still have a problem with the scope.
The scope.
We are still just counting from 0 to 11. Even if the rhythm is cool and elastic, that is a very short loop.
It is.
That's what, a few seconds of audio? If I hear that loop repeat 50 times, I'm going to go crazy. It's going to sound like a broken record.
You are absolutely right. If this were the entire system, it would be a glorified ringtone.
Right.
It would be technically interesting, but artistically unlistenable.
So how do they break the loop?
Well, they don't break the loop, they rotate it. This brings us to the circula object.
Okay, the source describes this as the rotating horizon.
Which is such a beautiful metaphor. Circula sits at the top of the patch structure, and its only job is to monitor that main counter.
The 0 to 11 one?
Yep. And every time the counter completes a full cycle, every time it goes 0 to 11 and resets circula, it triggers a state change.
So it's counting the measures, basically.
Sort of. But it's not just counting, it's shifting the entire context. Think of it this way. Imagine you have a physical map of a melody. 0 maps to C, 1 maps to E, 2 maps to G. A standard triad.
Okay, got it.
Now, the counter finishes the loop. Circula clicks over to its next position, position 2. It doesn't change the input numbers. The counter's still going 0, 1, 2. But Circula tells the mappa plus object to shift the point of entry into the scale.
So now that same 0 input doesn't trigger a C anymore.
Right. Maybe now 0 triggers E, and 1 triggers G, and 2 triggers B.
So the melody has physically moved up.
Or in inverted or shifted modulate, the source specifies we're working at a 7-tone minor scale. The notes available in the bucket are fixed.
So we aren't changing keys arbitrarily.
No, but Circula changes which notes from that bucket correspond to our 011 inputs.
Okay, that really clarifies the rotating horizon idea. If I'm standing in a room and I turn 30 degrees to the right,
Yeah.
the room hasn't changed. The furniture is all in the same place, but my perspective on it is completely different.
That's it, exactly.
Yeah.
And because the loop is short, only 12 steps, but the rotation might be, say, 7 steps or 5 steps, you create this amazing phasing effect.
Right.
The listener recognizes the shape of the melody. The rhythmic elasticity is familiar, but the harmonic content is constantly evolving.
It creates a long-form structure out of short-form data.
It extends the timeline, so instead of a 5-second loop, you might have a cycle that takes minutes to actually repeat its starting state.
It's so efficient, you get maximum output from minimum input.
And efficiency is key in generative systems.
Right.
You don't want to hard code a 20-minute symphony. You want to build a system that generates a 20-minute symphony from a handful of rules.
So we have the DNA, the 011, we have the body, which is the pitch-rhythm connection, and we have the environment, the rotating horizon. But let's talk about the voice. Because the source mentions there isn't just one sound, it's a harmonic dialogue.
Right. The system splits into 2 distinct voices, and this is where the sound design choices really reinforce that organic goal we were talking about.
One voice creates a tremolo modulated tone, which sounds like a texture thing. But the other one really caught my eye, Karplus-Strong synthesis.
Yes, this is a very specific choice.
So for the listeners who aren't, synthesis nerds, why does Karplus-Strong matter here? Why not just use a sample of a guitar or a standard sine wave beat?
Because Karplus-Strong is physical modeling. It's an algorithm that simulates the physics of a plucked string. You feed a burst of noise into a delay line, and it kind of filters itself out, creating a decay that sounds remarkably like a guitar or a harp.
So it has natural physics built into it.
Exactly. A sample is static. It's a recording of a moment. A sine wave is purely electronic. But physical modeling behaves like an acoustic instrument. If you pluck it harder, it rings differently. If you dampen it, it stops.
So sticking with the theme, it's adding another layer of fake organicness.
It is. It creates this percussive, plucked texture that contrasts with the second voice, which is that sustained, shimmering tremolo.
But here's what I found fascinating about the dialogue aspect. These two voices, they sound totally different. One is plucky and rhythmic, the other is long and drony.
Very different textures.
But they're locked together.
They are perfectly synchronized, as the text says.
And that's because they are both reading from that same 011 sheet music, right?
They're fed by the same root counter. They're just interpreting it differently. It's like two people watching the same event but describing it in different languages.
Or like a shadow. If I move my hand, the shadow moves instantly. There's no lag, no communication delay.
Oh, that's a great analogy.
They're just part of the same entity.
And because they are both constrained to that same coherent modal structure, that minor scale we discussed, they can never clash.
And this is an important point. In a random system, if you have two voices doing their own thing, eventually they're going to hit a dissonance that just sounds awful.
Oh, for sure. Randomness creates chaos. But here, since Mappa Plus is enforcing the scale on both voices simultaneously, every interval is, it's pre-approved, so to speak.
The conversation governed by rules, not by chance.
Exactly. You get this intricate interplay where the plucked voice might be dancing around the sustained voice, creating tensions and releases, but it never feels like a mistake.
It feels like intentional counterpoint.
Right.
And yet, there is no composer writing that counterpoint. There is just the counter and the constraint.
That is the beauty of the system.
It brings us to the philosophical core of the text. They use a term that I think is going to stick with me. Minimum logical intuition.
It's a powerful concept.
How do you interpret that? Minimum logical intuition.
For me, I see it as a rejection of brute force. We often think that complexity requires complex inputs.
Sure.
If you want to model a city, you think you need to draw every single building. If you want to write a complex piece of music, you think you need a complex melody to start with.
But this suggests that if your logic is sound, the input can be minimal.
Precisely. If the connections between the parts, the logic of connection, are intuitive and robust, you could feed in something as simple as count to 11, and the system will just blow.
It creates a high-resolution output from a low-resolution source.
It challenges the ego of the creator, I think. We like to think we are the source of the magic. But here, the magic is in the process, not the source material.
The source text invites us to visualize the geometry of the code, and I tried to do that while I was reading, imagining the numbers turning into angles and the angles turning into sound.
It really changes how you listen, doesn't it?
It really does. Instead of just letting the music wash over you, you start trying to reverse engineer it in your head.
Yeah.
You hear the pulse speed up and you think, high number. You hear the harmony shift and you think, okay, circula just rotated.
It turns listening into an active engagement with the system. You're listening to the architecture, not just the decoration on top.
It reminds me of looking at a fractal. You zoom in, it's complex. You zoom out, it's complex. But the equation that generates it is barely an inch long.
That's the absolute determinism payoff. A fractal isn't random. It is strictly mathematical. But it looks like a coastline. It looks like nature.
Right.
This music is the sonic equivalent of a fractal.
So we've come full circle. We started by saying determinism sounds robotic. But we found that with the right layers, the expr elasticity, the circular rotation, the Karplus-Strong physics,
Determinism can sound indistinguishable from life.
Which leaves us with a bit of a provocation, I think.
Oh, absolutely. It makes you wonder about the nature of our own creativity.
Right. We prize our human feel, our ability to improvise, to fluctuate our tempo, to converse musically. We think that separates us from the machines.
But if a simple counter and a few logic gates can replicate that human feels so convincingly then.
Are we just running a more complex version of circula in our own heads?
Are our emotions just complex expert objects responding to chemical inputs?
It's an uncomfortable question, but it suggests that the boundary between mechanical and organic is much, much blurrier than we like to admit.
So maybe creativity isn't about breaking the rules. Maybe it's just about finding a really, really elegant set of rules to follow.
And trusting the logic of connection.
I think that's the perfect place to leave it. Next time you're listening to something that feels incredibly complex and human, take a second to ask yourself, could this just be counting to 11